Hello everyone. See, in today's lecture we will see preparation of some selected dye intermediate. Preparation of some selected dye intermediate, and we will see here in this lecture naphthalene derivatives. Preparation of naphthalene derivatives as intermediates for some dye stuffs, isn't it? So let us see naphthalene derivative. That means we have to see preparation of naphthalene derivatives. Okay, first naphthalene derivatives we will see sulfur acid. Sulfur acid, isn't it? Let us see what is this sulfur acid and how it is prepared. See, I will write the structure of sulfur acid. See, this is the structure of sulfur acid. This is the structure of what? Sulfur acid. Let us see how it can be prepared. See, for the preparation of sulfur acid, we have to take beta-naphthol as a starting material. Beta-naphthol as a starting material, isn't it? Now this beta-naphthol is reacted with concentrated H2SO4. This beta-naphthol is reacted with what? Concentrated H2SO4 at lower temperature to get 2-naphthol 1-sulfonic acid. To get what? See, this is what? 2-naphthol and 1-sulfonic acid. 2-naphthol 1-sulfonic acid, isn't it? So this is what? Nothing but a sulfonation of 2-naphthol, sulfonation of beta-naphthol. This is the first step, isn't it? Now in second step, this is heated. This is heated and there will be a what? Rearrangement. There will be a what? Rearrangement. So this sulfonic acid group will get migrated at this position. Sulfonic acid group will get migrated at position number 6. Sulfonic acid group will get migrated at position number 6. So this is sulfur acid. This is what? Sulfur acid. So we can again see. So this is what? A beta-naphthol or 2-naphthol. Beta-naphthol is reacted with what? Concentrated H2SO4 at lower temperature around 261 degree Kelvin, isn't it? That much is the lower temperature. So beta-naphthol is reacted with concentrated H2SO4 at 261 degree Kelvin to get this sulfonic acid product. That means sulfonic acid group will get introduced at position number 1, and this is called, this intermediate, it's called oxy-Tobias acid. This intermediate is called oxy-Tobias acid, isn't it? Now this oxy-Tobias acid, or I can say 2-naphthol 1-sulfonic acid, 2-naphthol 1-sulfonic acid or oxy-Tobias acid is on heating. There will be a rearrangement of the sulfonic acid group. Okay, this sulfonic acid group will get shifted over this position, that is position number 6. carbon of this benzene ring, isn't it? And there will be a formation of this product which is called Schaefer acid. There is formation of this product which is called what? Schaefer acid. So Schaefer acid is nothing but what? 2-naphthol 6-sulfonic acid. 2-naphthol 6-sulfonic acid. Now let us see next naphthalene derivative intermediate. Okay, I hope you have understood this, how Schaefer acid can be prepared. Now let us see next point. See, next synthesis is Tobias acid. Next synthesis is Tobias acid. Let us see it. See, next synthesis is what? Tobias acid. See, what is the structure of Tobias acid? See, I will write Tobias acid. Just now we have seen oxy-Tobias acid. Just now what we have seen? Oxy-Tobias acid. Isn't it? Now let us see what is Tobias acid. See, this is what? Tobias acid. What is this? Tobias acid. Now let us see how it can be prepared. See, for the preparation of Tobias acid, we have to start from 2-naphthol 1-sulfonic acid. 2-naphthol 1-sulfonic acid, or we can start from 2-naphthol or beta-naphthol. Okay, so 2-naphthol or beta-naphthol on sulfonation at lower temperature gives what? 2-naphthol 1-sulfonic acid. So this is what? Oxy-Tobias acid. This is what? Oxy-Tobias acid. Why it is called oxy-Tobias acid? Because here NH2 functionality is replaced by what? Hydroxyl group. Hence it is called what? Oxy-Tobias acid. So now this oxy-Tobias acid is reacted with ammonium sulfate, and ammonia, isn't it? So oxy-Tobias acid is reacted with what? Ammonia in presence of ammonium sulfate at 423 degree Kelvin and about 10 atmospheric pressure. That means high temperature is also required and pressure is also required. Both temperature and pressure will required for this reaction. Then this hydroxyl group will get replaced by NH2 functionality. Okay, so what is the source of NH2 functionality? This ammonium sulfate and ammonia is the what? Source of NH2 functionality. So what we will get? There will be a replacement of hydroxyl group by NH2 group, and that is, this is what? Tobias acid. What is this? Tobias acid. So understood? Have you understood how Tobias acid can be prepared? Okay, see, for the preparation of Tobias acid, we have to take what? Oxy-Tobias acid, and that oxy-Tobias acid is nothing but what? 2-naphthol 1-sulfonic acid, and this 2-naphthol 1-sulfonic acid, that we have to react with what? Ammonia in presence of what? Ammonium sulfate, NH4 twice, SO4 ammonium sulfate at 423 degree Kelvin at about 10 atmospheric pressure. So what we will get? Tobias acid, isn't it? So there will be a replacement of this hydroxyl group by NH2 group, and this reaction is also called, we can say, that is, we have seen this reaction, isn't it? We have seen this reaction, that is replacement of hydroxyl by NH2 is called Becquerel reaction, or you may say Becquerel reaction. Isn't it? Replacement of hydroxyl, phenolic hydroxyl. Remember it, phenolic hydroxyl by NH2 functionality by using this ammonium sulfate and ammonia is called Becquerel reaction. It's called Becquerel reaction. Okay. So this is what Tobias acid. Now let us see next synthesis. Next synthesis is Naphthionic acid. Naphthionic acid. Okay, what is the structure of naphthionic acid? See, naphthionic acid, structure of naphthionic acid is NH2 SO3H. Okay, structure of naphthionic acid is what? NH2 SO3H. So, okay, now let us see how this naphthionic acid can be prepared. See, for the preparation of naphthionic acid, we have to start from alpha naphthylamine. We have to start from what? Alpha naphthylamine. What is this? Alpha naphthylamine. Isn't it? Now this alpha naphthylamine alpha naphthylamine is reacted with concentrated H2SO4, is reacted with what? Concentrated H2SO4. So what you will get? You will get a sulfate derivative. A bisulfate derivative, that is salt. Okay, salt of this amino group and this acid. So this what we will get, NH3 plus HSO4 minus. Now in next step we will heat this product around 260 to 280 degrees Celsius, and this is called baking process. This is called what? Baking process. Isn't it? This is called what? Baking process. Now when we will heat this product, when we will heat this intermediate, there will be a loss of water molecule. There will be a loss of water molecule from this salt. And what we will get? See, we will get naphthyl sulfamic acid. What we will get? Naphthyl sulfamic acid. What is this? Naphthyl sulfamic acid. Isn't it? So there is loss of water molecule. Water molecule will get lost when we will heat this intermediate. Isn't it? When we will heat this salt, there will be a loss of water molecule, so we will get naphthyl sulfamic acid. Now see, in this process is called what? Baking process. Now in next step, when we will heat that naphthyl sulfamic acid again, isn't it? When we will heat that naphthyl sulfamic acid again, there will be a rearrangement. There will be a what? Rearrangement of this sulfonic acid group and this proton, that is this hydrogen, isn't it? So this sulfonic acid group will get migrated here and this hydrogen will get migrated over nitrogen atom. So there will be a what? Rearrangement. What you will get? You will get naphthionic acid. This is what? Naphthionic acid. What is this? Naphthionic acid, isn't it? So how naphthionic acid can be prepared? Alpha naphthylamine is reacted with what? Concentrated sulfuric acid around 60 to 80 degrees Celsius. So what we will get? We will get this type of salt. Okay, so this is called bisulfate salt of alpha naphthylamine. Now this bisulfate salt of alpha naphthylamine is again heated around 260 to 280 degrees Celsius, and this process is called what? Baking process. Okay, when this salt will undergo baking process, then there will be a what? There will be a loss of water molecule. It will undergo loss of water molecule, and there is formation of what? Naphthyl sulfamic acid. We know what is the structure of sulfamic acid. This is the structure of sulfamic acid, isn't it? So there is formation of naphthyl sulfamic acid, and now this naphthyl sulfamic acid is on heating. It will undergo rearrangement to form naphthionic acid. So this is what? Naphthionic acid. Okay, so you might have thought that this synthesis of naphthionic acid is resembles with what? Synthesis of sulfamic acid. Okay, we have seen synthesis of sulfamic acid from aniline in the benzene derivatives. Okay, same kind of synthesis we have to apply here. Same kind of step we have to apply here for the synthesis of naphthionic acid from naphthylamine, isn't it? Now let us see next synthesis. See, next synthesis is Nevill winter acid, which is also called NW acid. Nevill winter acid, which is also called NW acid. Let us see how Nevill winter acid can be prepared. See, what is the structure of Nevill winter acid? That I will write here. Nevill winter acid, C, it is a hydroxyl derivative of naphthionic acid. Okay, what is it? Nevill winter acid, which is also called NW acid. This is also called what? NW acid. Okay, so what is it? It is a hydroxyl derivative of naphthionic acid. It is a hydroxyl derivative of naphthionic acid. Now let us see how it can be prepared. So for the preparation of Nevill winter acid, we have to take naphthionic acid. We have to take what? Naphthionic acid. So naphthionic acid is reacted with sodium bisulfite. Is reacted with what? Sodium bisulfite. So what the product we will get? That we have to decompose in alkali. Okay, in first step we have to react naphthoic acid. What is this? Naphthoic acid, isn't it? Naphthoic acid. Now this naphthoic acid we have to react with sodium bisulfite at some temperature, okay, around 160 degrees Celsius, and then what the product we will get? That product we have to decompose in what? NaOH. So we will get replacement of NH2 functionality by hydroxyl functionality. Replacement of NH2 functionality by hydroxyl functionality, or we can say replacement of NH2 group by hydroxyl group. So this is what nevyl winter acid, or it is also called NW acid. So this is a reverse of Buchrer reaction. It is a what? Reverse of Buchrer reaction. Reverse of Buchrer reaction. See, in Buchrer reaction, what we are doing? We are converting phenolic group, that is phenolic hydroxyl group, into amino functionality, isn't it? And in this reaction, we are converting NH2 functionality into what? Phenolic hydroxyl group. Hence, it is what? Reverse of Buchrer reaction. So nevyl winter acid is synthesized through what? Reverse Buchrer reaction approach. Nevyl winter acid is synthesized through what? Reverse Buchrer reaction approach. So what is it? So take naphthoic acid and react it with what? Sodium bisulfide, and then what? Sodium hydroxide. So we will get what? Nevyl winter acid. It is also called NW acid. Now let us see next synthesis, Cleve acid. Cleve acids. See, there are two types of Cleve acids. Okay, let us see what are they. Next synthesis is what? Cleve acids. Cleve acids. There are two types of Cleve acid. Let us see what are they. One is this, and second one is this. See, what is this? 1, 2, 3, 4. Sorry. What is this? 1, 2, 3, 4, 5, 6. Okay. So this is Cleve 6 acid. What is this? Cleve 6 acid. And what is this? Let us see. 1, 2, 3, 4, 5, 6, 7. So this is Cleve 7 acid. So there are two types of Cleve acid. One is Cleve 6 acid and second one is what? Cleve 7 acid. Okay. Now let us see how they can synthesize. See, for the synthesis of Cleve 6 and Cleve 7 acid, we have to start from beta-naphthol. We have to start from beta-naphthol or 2-naphthol. So beta-naphthol is on, sorry, we have to start from naphthalene 2-sulfonic acid. Naphthalene 2-sulfonic acid. Isn't it? For the synthesis of Cleve 6 and Cleve 7 acid, we have to start from naphthalene 2-sulfonic acid. Now this naphthalene 2-sulfonic acid is on reaction with concentrated nitric acid and concentrated sulfuric acid. That is, it is a reaction with nitrating mixture. It will give nitro derivatives, two nitro derivatives. What does it will give? It will give mixture of nitro derivatives. So we will get this nitro derivative along with second nitro derivative. Along with this nitro derivative. Isn't it? See, next step, these nitro derivative are on reaction with iron HCl. These nitro derivatives are on reaction with what? Iron HCl. That is Beck-Hamp reduction. What is this? Beck-Hamp reduction. What is this? Beck-Hamp reduction. So this nitro group will undergo reduction, and that is, it will get converted into NH2 functionality. Both the nitro group will get converted into NH2 functionality. So what we will get? We will get clave 6 acid and clave 7 acid. What we will get? This is clave 7 acid and this is clave 6 acid. So we will get a mixture of clave 6 acid and clave 7 acid. In this way we can prepare clave 6 acid and clave 7 acid from naphthalene to sulfonic acid, isn't it? So naphthalene to sulfonic acid, in first step it is reacted with nitrating mixture, that is concentrated nitric acid and concentrated H2SO4 to get a mixture of nitro derivative. Okay, that means there is what? Insertion of nitro group at this position and at this position of another benzene ring. Okay, nitro group is not getting introduced over this benzene ring which is having sulfonic acid group. Okay, so this benzene ring is quite electron deficient, hence nitro group will get introduced in this benzene ring, that is at this position of this benzene ring and at this position of this benzene ring, isn't it? So what we will get? We will get two nitro derivatives, and that nitro derivatives on reduction, Beck-Hamp reduction, that is with iron and hydrochloric acid, we will get corresponding amino derivatives of 2-naphthol sulfonic acid, and that are clave 6 acid and clave 7 acid. Okay, so I hope you have understood how Schaefer acid can be prepared, how Tobias acid can be prepared, how naphthionic acid can be prepared, how Nevill-Winther acid can be prepared, and how clave acids can be prepared, how clave acid can be prepared. Okay, so I hope you have understood this topic very well. Okay, wish you happy learning, wish you all the best. Thank you very much.